Right now, somewhere in the Australian outback, a train longer than 80 football fields is dragging nearly 100,000 tons of iron ore through the desert. These machines are absolute monsters, and some of them roll through your own backyard. So, you're driving down Interstate 80 in Nebraska. The planes stretch out forever under a massive sky, and then you spot it. A freight train snaking along the horizon. It just keeps going and going and going. That thing is hauling everything from Iowa soybeans to California electronics, and it might be over 2 miles long. In America, where railroads built this country since the golden spike of 1869, these iron horses move about 40% of all our long-distance freight. We're talking 1.7 billion tons every single year. The trains doing this work are getting longer and longer. But here's where things get wild. Go global, and you find freight monsters that make American trains look almost modest. The world record holders can stretch nearly 5 miles. That's longer than some entire towns. These beasts push the absolute limits of physics and engineering, and they exist for one simple reason. Moving more stuff in fewer trips saves serious money and burns less fuel. The history of long trains. Now, before we get into the countdown, you need to understand how we even got here in the first place. The quest for longer trains started way back in the early 1800s when railroads first appeared and changed transportation forever. Before trains, moving goods across the country took weeks by wagon. Rails cut that down to days, but running longer trains? That came later when railroad companies realized something obvious. Why run 2 trains when one giant haul could do the same job for less money? Early records seemed tiny by today's standards. Back in 1929, the Atchison, Topeka, and Santa Fe Railway ran a 118-car coal train in Colorado. That was about a mile long, and steam locomotives pulled it while huffing like overworked plow horses. Those old steam engines had serious limits, though. The boilers couldn't sustain enough power for heavy loads over long distances without risking derailments or even explosions. World War II pushed innovation forward when American railroads hauled war supplies in trains up to 150 cars long. After the war, diesel-electric locomotives took over and changed everything completely. These new engines offered way more reliable power distribution across the entire length of the train. The 1966 American record. America actually etched its name in the record books pretty early. On October 31st, 1966, the Norfolk and Western Railroad set a benchmark that stood for decades. Their coal train stretched 4 miles, which is 6.4 kilometers, with 500 hopper cars loaded with 48,170 tons of bituminous coal traveling from Yeager, West Virginia to Portsmouth, Ohio. 6 General Electric diesel-electric locomotives producing 21,600 combined horsepower pulled it along at about 10 miles per hour over hilly Appalachian terrain. Crews joked that walking the train's length took longer than driving through some small towns in the area. That run provided rail's massive advantage over trucking, since moving the same cargo by road would have required hundreds of trucks clogging highways. Australia takes the lead. Australia pushed past American records during the resource boom years that followed. In 1972, a Hammersley iron train hit 2.4 miles with 240 cars. By 1991, BHP Billiton reached 3.6 miles. Then came the legendary 2001 run that still holds the record today, and we'll get to that monster soon. How long trains work. So, let's talk about what actually makes a train long in the first place and how engineers pull this off. A standard freight car runs about 50 to 60 feet and weighs around 100 tons when fully loaded. Stack 200 of those cars together and you get 10,000 to 12,000 feet of train, roughly 2 miles, weighing 20,000 tons. Pulling that weight makes 3 to 8 locomotives pumping out anywhere from 12,000 to 30,000 horsepower total. Modern trains use AC traction motors instead of the old DC systems from before the 1990s. That switch boosted adhesion significantly, which means trains can climb steep grades without their wheels slipping on the rails. The couplers holding all these cars together are called Janny knuckles. They are interlocking jaws that can handle 1 million pounds of pulling force, which is absolutely necessary when you're yanking thousands of tons up a mountain grade. When a train goes around a curve, it hunts, which means it oscillates back and forth like a sidewinder snake moving through sand. Engineers deal with this problem using end-of-train devices, basically GPS-equipped units at the back that monitor the air brakes constantly. Those brakes send pressure signals at 600 pounds per square inch, and on a 2-mile train, it takes several minutes for that signal to travel the whole length from locomotive to caboose. Modern train technology. Modern technology helps manage these giants too. Positive train control, which the government required after some devastating crashes in 2008, automatically hits the brakes if a train exceeds safe speeds. GPS tracking and artificial intelligence systems now predict when wheels will wear out before they fail, which cuts maintenance costs substantially. Fuel efficiency? A 2-mile train gets about 3 to 4 miles per gallon, which sounds terrible until you realize trucks only get a fraction of that efficiency when measured per ton of cargo moved. Trains produce way less carbon dioxide per ton mile than any other form of ground transportation. One crucial innovation is distributed power. On really long trains, engineers place remote locomotives in the middle and at the rear of the consist. Radio signals synchronize these units with the lead engines so they all pull together. This prevents something called run-ins, where cars bunch up and crash into each other on downhill grades. Without distributed power, trains over a mile long would tear themselves apart going through mountains. The countdown begins. All right, now let's get into the actual countdown. We're starting at number 7 and working our way up to the absolute king of the rails. Number 7, Swiss Alps Passenger Train 2022. Coming in at number 7, we have the Swiss Alps Passenger Train from 2022. This one was special because it hauled passengers through some of the most beautiful scenery on Earth. The Rudrastra Railroad put together 25 rail cars stretching 1.18 miles through the Swiss Alps on a route that's actually a UNESCO World Heritage Site. For a passenger train, that's seriously impressive. Most passenger trains prioritize comfort over cargo capacity, so they stay much shorter than freight haulers. Compare this to Amtrak routes like the California Zephyr, which covers 1,100 miles of track but uses way fewer cars in its actual consist. Number 6, Mumbai local trains. Number 6 takes us to India and the Mumbai local trains during rush hour. These commuter trains stretch about 1.5 miles and somehow cram around 5,000 people inside each one. That's not a typo. 5,000 human beings packed into one train during peak commute times. People hang out of doorways and sit on the roofs because there's simply nowhere else to fit. The density is almost unbelievable, and it shows how different countries solve their transportation problems in completely different ways. Number 5, the Rio Tinto AutoHaul, Australia. At number 5, we have the Rio Tinto AutoHaul system in Australia. These trains run between 1.5 and 2 miles long with 240 cars each. And here's the crazy part. They've been fully autonomous since 2018. No driver sits in the cab. No human touches the controls. The trains run 24 hours a day, 7 days a week, moving 1.4 billion tons of iron ore every single year completely on their own. It's basically a preview of what might be coming to American rail yards in the future. The technology works, and it works at absolutely massive scale without human intervention. Number 4, Mauritania iron ore train. Number 4 brings us to one of the most unique trains on Earth, the Mauritania iron ore train. This desert crawler stretches about 2 miles and hauls 25,000 tons of ore across 437 miles from the mines of Zouéret to the port of Nouadhibou through the scorching Sahara Desert. The length varies since they add cars based on the load, sometimes reaching up to 300 cars in a single consist. But here's what makes this train truly special. The open wagons double as passenger cars for locals who need to travel across the desert. People literally hitch rides on ore cars, sitting on top of iron ore for hours in blistering heat. This train's a lifeline for about 2.5 million people living in that remote region who have no other way to travel. Number 3, Sishen to Saldanha ore train, South Africa. Number 3 on our countdown is the Sishen to Saldanha ore train in South Africa. Transnet Freight Rail operates this daily iron ore shuttle, and it hits 2.5 miles with over 200 cars hauling 34,000 tons from Northern Cape mines to Atlantic ports. This is officially the world's heaviest regularly scheduled freight train, meaning it runs on a set timetable, carrying this massive weight every single time it departs. Africa's incredible mineral wealth requires serious infrastructure, and this train is proof of what that takes to move. Number 2, Indian Railways Rudrastra. Now we're getting into the real heavyweights that dwarf everything else. Number 2 is the Indian Railways Rudrastra, which just started running in August 2025. This beast stretches 2.8 miles with 100 cars carrying cement and clinker from Sanagar to Dankuni. During efficiency tests, it hit speeds of 47 miles per hour, which is impressive for something that long and heavy. India has been pushing hard to modernize its rail network and compete with other major economies, and this train shows they're absolutely serious about becoming a global rail powerhouse. Number 1, BHP iron ore train, Australia, world record holder. And finally, number 1, the longest train ever assembled in human history, the BHP iron ore train in Australia's Pilbara region. On June 21, 2001, this absolute monster stretched 4.57 miles, which is 7.353 kilometers for everyone outside America. It had 682 wagons hauling 82,000 tons of iron ore, and some sources put the total weight at over 99,000 tons. 8 General Electric locomotives with 32,000 combined horsepower distributed power along the entire length to manage the snake-like flex around curves. It took 16 hours just to assemble this train properly, and it held the Guinness World Record for over 2 decades. To put that length in perspective, you'd need 500 semi-trucks to move the same amount of cargo. The daily trains in that region now average 1.5 to 2 miles, but that 2001 record setter remains absolutely unbeaten to this day. American trains today. Wait, what about American trains? Where do we stack up against these global giants? Here's the thing. American railroads don't chase Guinness records the same way Australian ore haulers do. Our trains are more like marathon runners than one-time showstoppers. The terrain's different too. American tracks are denser with more curves and way more grade crossing compared to the flat open Pilbara Desert. Regulations cap train lengths at 7,500 feet in some areas, though companies get waivers pretty regularly. Union Pacific operates America's longest railroad network at 32,000 miles of track, and their intermodal trains in the Southwest routinely exceed 2.5 miles. About 10% of their entire fleet ran longer than that mark in 2025. Their record run happened in 2023, a 3.3-mile intermodal train with 288 cars traveling from Chicago to Los Angeles, loaded with double-stacked containers piled too high like Lego towers. That's longer than the distance from Times Square to the Brooklyn Bridge. BNSF Railway, which Warren Buffett's company Berkshire Hathaway owns, dominates the coal business completely. From Wyoming's Powder River Basin and the Black Thunder Mine specifically, their unit trains stretch 1.5 to 2 miles, with over 125 cars hauling 15,000 tons to power plants in Texas and beyond. In 2025, they started pivoting toward renewable energy cargo, hauling wind turbine blades longer than a Boeing 737 wingspan across the Great Plains. CSX pushes trains up to 16,000 feet, which is about 3 miles along the eastern corridors. Norfolk Southern runs their daily mixed freight operations at around 7,000 feet through Virginia. The median length for all Class 1 railroad trains hits 5,300 feet in 2023, which is basically 1 mile. That number jumped 20% from just a decade earlier as companies squeezed more efficiency from their networks. In the Texas Permian Basin, oilfield trains hit 2 miles regularly, stacked high with frac sand for the drilling operations. The problems with long trains. Now, here's something we need to talk about honestly. These long trains create real problems for American communities that live along the tracks. Class 1 railroads save about $3 billion every year in fuel by running longer trains. The economics make perfect sense from their perspective. But in 2023, the median train blocked grade crossings for 16 minutes. Longer trains double that time easily. Imagine a 3-mile train stopping Interstate 35 in Dallas for half an hour during rush hour. Ambulances get detoured miles out of their way. Kids show up late to school. A viral video from Ohio showed a blocked emergency room entrance, and that sparked a whole social media movement calling for change. Safety concerns. Safety concerns are serious too. Data from the National Transportation Safety Board shows longer trains derail twice as often as shorter ones, usually from coupler failures or uneven load distribution. Remember East Palestine, Ohio in 2023? That vinyl chloride spill came from a 1.7-mile train. 50 cars jumped the tracks and caught fire. Around 2,000 people had to evacuate their homes. Government reports cite communication blackouts mid-train and crew fatigue from 12-hour shifts as a major contributing factor. When a long train derails and hazardous materials are involved, firefighters sometimes have to trek a full mile along the tracks to reach the problem cars and uncouple them safely before the situation gets worse. Congress ordered a Transportation Research Board study in 2024 specifically about long freight train safety. The findings confirmed more blocked crossings and significant impacts on Amtrak passenger service. Technology like virtual crossing symbols and improved communications helps somewhat. Meanwhile, railroad unions push for shorter trains and more crew members, while the companies point to their efficiency gains, even though they've cut about 20% of railroad jobs since 2019 through a system called precision scheduled railroading. Environmental impact. The environmental picture is genuinely mixed. Rails move 16 tons of cargo per gallon of fuel compared to trucks moving about 0.1 tons per gallon. That's a massive advantage for fighting climate change. Rail transport produces 75% less greenhouse gas than trucking overall, but coal trains release particulates into the air near communities. Derailments risk chemical spills into waterways and soil. The 2021 infrastructure bill put $66 billion toward rail improvements, including grade separations in high-traffic areas like California's Central Valley, where trains and cars constantly conflict. For communities along rail corridors, this is deeply personal. In Tehachapi, California, residents deal with 100 trains per day, some stretching 2 miles, shaking their homes and interrupting their sleep. Texas lawmakers have been vocal about the crossing problems, yet the rail industry sustains 1.2 million American jobs, paying $74 billion in wages annually, so the economic stakes cut both ways. The future of freight rail. Let's look at where all this is heading in the coming years. The global freight rail market is projected to hit $567 billion by 2035, representing a remarkable 40% growth from today. American intermodal shipping is booming thanks to online shopping, with 2025 volumes up 8% despite trade tensions and tariff threats. These trains are going to keep getting longer and more sophisticated as demand grows. Technology is pushing boundaries fast. A Los Angeles company called Parallel Systems is testing autonomous battery-powered rail units on BNSF tracks, eyeing 3-mile unmanned runs in the near future. Internet of Things sensors now predict mechanical failures before they happen. Artificial intelligence optimizes routing to cut idle time by 30% compared to traditional dispatching. Union Pacific is piloting hydrogen-powered locomotives in California that produce zero emissions over 300-mile hauls, running completely clean. Sustainability pressure keeps building from consumers and regulators alike. New aerodynamic railcar designs reduce drag significantly. Regenerative braking systems recoup about 10% of energy that used to be wasted as heat. Intermodal hubs like the one in Savannah slash the miles trucks need to travel for final delivery. Challenges ahead. Challenges remain, though. About 40% of American rail infrastructure dates back to before 1900. That aging network needs about $25 billion in upgrades every single year just to maintain current service. Amtrak is pushing for priority over freight trains to improve its long-haul on-time performance for routes like the Empire Builder crossing the northern states. The Federal Railroad Administration is considering 10,000-foot caps on train length in sensitive areas. For rail fans, spotting these giants from an overpass in Omaha or watching them snake through the Mojave Desert is pure thrill. Apps track train movements in real time, turning waits at crossings into spectator events. For people dreaming about the distant future, Hyperloop pods and magnetic levitation trains might eventually compete with traditional rail for certain routes. But conventional trains have proven scale, moving 40% of American freight reliably for over 150 years. That track record's incredibly hard to beat with unproven technology. When you think about what these trains represent, it's really about human ambition and the drive to build systems that move mountains of material across entire continents efficiently. From the Norfolk and Western coal drag of 1966 to Australia's modern autonomous ore haulers, the longest trains symbolize our push to stretch supply chains, fuel factories, and keep billions of people fed and supplied.